Welcome back to Aurora Tech Channel. Today, I will test the new Ortur R2. This is a fully enclosed compact laser engraver that offers multiple laser module options, including 10-watt and 20-watt diode lasers, a 1.3-watt IR laser, or a combination package with both diode and IR modules. The working area is 300 by 210 millimeters. The total table space required is about 18.5 inches by 20 inches, including the ducting. The laser modules are swappable, but it's not a quick swap design. You'll need to unplug both the cable and the laser module when switching between the diode and IR lasers. The machine comes with an air assist port, and depending on the bundle you choose, it may include an air pump, or you can use a regular aquarium pump. The motion system uses linear rods on the y-axis and palm wheels on the x-axis. There's an exhaust fan at the back, allowing you to connect your own ducting or use the one provided with the machine. For safety features, it includes a tilt sensor, a cover open sensor, multiple flame sensors, 4 in the corners and 1 under the laser module, an emergency stop switch, and a safety lock. In terms of software, you can connect the machine to your computer via USB and use the free Laser Gerbil software, or opt for the $99 Lightburn Core software for more advanced control. It also supports Wi-Fi connectivity through its own app for simple engraving jobs, or you can save your frequently used files on a micro SD card and run the machine completely offline using the touchscreen. Overall, this is a basic enclosed laser engraver that won't break the bank. I would like to thank Ortur for sending this machine and for sponsoring today's video. As always, even though this is a sponsored review, we won't hold back from pointing out any cons or issues found during testing. I believe this helps buyers have a reasonable expectation before deciding whether to buy the machine, and also provides feedback for the manufacturer to improve on in future updates. With that said, let's get started. The machine came in a shipping box. Inside, it had another retail box. The machine was well protected, and the user manual and other accessories were all packed inside the machine. Besides the machine, we have the power supply, safety goggles, some tools, cables, ducting, a thin metal sheet to protect the base plate, a set of keys to lock the machine, a micro SD card, and a small acrylic gauge for focal length setting. There is no honeycomb bed. Instead, it came with 4 triangular prisms for cutting. Depending on which package you order, for this testing machine, the 10-watt diode laser module was pre-installed, and it also came with the 1.3-watt IR laser, as well as the air assist pump. Besides the user manual, it also came with a detailed printed parameter table for different laser modules and materials, including the 2 to 20-watt diode and the 1.3-watt IR module. There is a calibration board for the camera, but it only works with their own app. If you use Lightburn, you need to print one from the Lightburn website for camera calibration. At the back, you can connect the ducting to exhaust the smoke outside and the air tube for the air assist pump. We can now turn on the machine. It starts by homing itself, and it seems all stepper motors and limit switches are working normally. On the touchscreen, there is not much to control. When you click the Download App button, it shows a QR code that redirects to the App Store. You can set up Wi-Fi from the screen by selecting the SSID and entering the password. Or you can use the app to send the Wi-Fi info to the machine by pressing the power button 5 times. Just follow the instructions in the app and you should be connected. It will ask which module you are using. I will select the 10-watt diode. Let's select New Creation to test the machine. For material, select 3mm plywood. I will engrave some simple text. I tried to change the font, but the font selection is very limited. Okay, I will just pick this tech-looking font. Once I select Process, it shows the speed and power settings. I will stick with them as I am working on thin 3mm plywood. I will use the acrylic gauge to set the focal length. I will also let it draw a preview frame. The position looks good, and we can now start the job. The job finished in about 2 minutes and 20 seconds. It seems everything is working normally. Instead of using the phone app, I personally prefer using Lightburn on a computer for laser engraving, so I will continue the test using Lightburn. Just open Lightburn and see if the software can find the machine automatically. It found an Ortur 300 by 210 engraver connected via USB. I will keep all default settings and just change the name to Ortur R2. The camera works as a USB webcam since it's connected to the computer with another USB cable. First, we will calibrate this camera just like a regular webcam. We will perform a full calibration and print the circle pattern from the Lightburn website. Then follow the software instructions and place the alignment paper at different positions. Starting with the center, capture the image, and if the score is 0.5 or less, that's good, and we can move on to the next position. After all positions are done, we can do an alignment test. It will engrave a test pattern, so I'll just put a piece of cardboard. Then, we need to select those 4 points in the software as close to the center as possible. The software will adjust and compensate for lens distortion, especially in the corners. After the calibration is done, I'll reload the background and try to add some text and align it using the camera, starting from the center of the circle. The 3000 millimeters per minute speed and 60% power are a bit too much, but it should still be fine. Let's draw a preview frame. It looks good, so I'll start the job. Okay, let's zoom in and see how accurate it is. Since we started at the center of the camera, it's generally quite accurate. On the finished job, the letter A shifted about 0.5 millimeters upward, while the left and right alignment are basically accurate. The accuracy is similar to other fixed webcams positioned at the center of the machine. It's generally usable, but if you change the material thickness or place your job near the corners, it's best to use the preview frame to confirm alignment, as it could otherwise be off. Okay, let's start some real tests using Lightburn. I'll do some engraving and cutting on this plywood. I'll follow the parameters on the printed table for all my tests, and if I need to make any adjustments, I'll mention them. Starting with engraving a logo using fill mode at 15,000 millimeters per minute and 100% power. At first, I forgot to turn off the air assist for engraving, so I'll zoom in later to see how it affected the text engraving. After the fill mode logo is done, I'll engrave another one using line mode at the same speed and cut it out at 300 millimeters per minute with 100% power. If you hear a clicking sound, that was me turning on the air assist pump manually. Here are the results. You can see the first half of the engraving isn't very clean because I forgot to turn off the air assist pump. After that, the engraving looks better, the logo is a bit light, but overall the fill mode result looks fine. However, when using line mode, the vibration is more noticeable as the laser head moves in different directions, so it doesn't look as good as the fill mode. The cutting with air assist is fairly clean, and it cut through the 3mm plywood in a single pass at 300 millimeters per minute. Next, I'll run some power tests for photo engraving, starting with the suggested 15,000 millimeters per minute for plywood. This job took a little over 6 minutes. I then tried speeding it up to 20,000 millimeters per minute with the same 100% power, and another one at 15,000 millimeters per minute with 80% power. Here are the results. All of them finished in about 6 to 7 minutes, and the speed didn't make a big difference. I think the last one looks best. I'll use the same settings and reduce the power to 80% to engrave a larger image. This time, it took about 26 minutes. The result is quite good for a 10-watt module that combines two 5-watt lasers. It's definitely better than higher power modules like 20 watts or 40 watts, which combine 4 or 8 5-watt lasers and produce a larger dot. A 10-watt diode isn't very powerful, but it should still be able to handle thinner wood around a 1/4 inch thick. I'll start with 5mm plywood. The laser cut through most of the plywood. You can see it penetrated the board. However, the piece didn't drop after the first pass, so I ran another pass. Halfway through, the piece dropped, meaning the first pass almost cut through. You could probably snap it apart or run another pass. The result is clean, and even though this is just a 10-watt module, it cuts 5mm plywood quite well at 250 millimeters per minute with 100% power. Next, I'll try thicker 8mm plywood. The suggested parameters are 100 millimeters per minute with 100% power. The first pass didn't cut all the way through, and I didn't see the laser penetrate the board like with the 5mm piece. On the second pass, I could see the laser break through, but the piece still didn't drop. I didn't want to run a third pass since it would char the plywood even more, so I snapped it apart. A few points were still connected, and the edge wasn't as clean as the 5mm one. The slower you cut, the harder it is to get a clean edge, but it's still acceptable. I will then try some acrylic. As a diode laser, it can only engrave on dark-colored acrylic. If you need to engrave on clear acrylic or glass, you'll need to apply marking film, which burns off during engraving and transfers the design onto the clear surface. The suggested parameters for acrylic engraving are 20,000 millimeters per minute and 100% power, slightly faster than for plywood. This job took about 3 minutes and 20 seconds to finish. Using scan mode with this 10-watt module on acrylic looks good, and I have no complaints. For cutting 5mm acrylic, the suggested parameters are 100 millimeters per minute and 100% power. Since I want a smoother cut, I increased the speed to 1000 millimeters per minute at 100% power and used multiple passes. It cut through completely in 12 passes. You can see the step-down lines when zooming in closely, but they aren't very noticeable from a distance. I'll try another cut using the suggested 100 millimeters per minute and 100% power to compare the results. The piece dropped after 2 passes. Let's take a closer look. As you can see, using a slower speed cuts through in fewer passes, but the plastic melts more, and the surface isn't as clean as when using multiple faster passes, which generate less heat during cutting. Next, I'll engrave and cut a piece of leather. This is raw leather without any paint or coating. The suggested parameters are 20,000 millimeters per minute and 60% power for engraving. After that, I'll use 300 millimeters per minute and 100% power, the same settings as 3mm plywood, to cut it out. The whole job took about 4 minutes and 7 seconds. The engraving result on leather is quite good. The marks are dark and clean. For cutting, some edges are slightly charred, as I manually turned on the air pump about 2 seconds after the cut started. The back of the leather is still quite clean. Before switching to the IR laser, I'll try some metal engraving. I'll start with a coated steel dog tag. For this type of coated metal, the laser actually engraves on the coating. It doesn't matter what the metal itself is. So the suggested parameters are quite fast at 6,000 millimeters per minute and 100% power. However, one problem is that the vibration causes the lightweight tag to move, and you can see it shifting during the job. The result isn't great, but the engraving itself looks fine. Next, I'll try a stainless steel tag and secure it with painter's tape. The suggested parameters are 2,000 millimeters per minute and 100% power. This time, the tag stayed in place, and the result is much better. If you want the text to appear darker, you can increase the line density. Currently, I'm just following the suggested 15 lines per millimeter. I'll now switch to the IR module. As you can see, the diode module connectors are completely different from those of the IR module. The IR module is backward compatible with older machines. I found it's the same as the one used on the Ortur Master 2, which I reviewed 4 years ago, so it allows you to swap out the laser module directly. However, for the R2, you have to remove the entire laser head and cable assembly, then replace it with the IR set and secure the new cable along the X-axis with zip ties. I'll start with my favorite material for the IR laser, the coated aluminum card. I'll engrave the same picture so we can compare it with the one engraved using the diode laser on wood. I placed a piece of cardboard underneath to protect the surface, as I made the photo slightly larger than the card to avoid spending too much time aligning it. For this coated aluminum card, I couldn't find the parameters on the table. I first tried 4,000 millimeters per minute at 100% power, which was too strong, so the final result you see was done at 6,000 millimeters per minute and 100% power. The job took a little over 20 minutes to finish, while engraving the same size on wood with a diode laser at 15,000 millimeters per minute only took 6 to 7 minutes. Still, the result is beautiful. The details in the picture, even in the background, are clear. Compared to the engraving on plywood with a diode laser, the difference is huge. Next, I'll engrave on raw aluminum. At first, I wasn't sure if this 1.3 watt module would be powerful enough, so I ran a simple line test to see if it could leave marks on a piece of raw aluminum with a rough surface, using the suggested 10,000 millimeters per minute and 100% power. It worked, so I proceeded with the same text in fill mode. Since this 5mm thick aluminum piece is much heavier than the dog tag, it didn't move even without being secured. Despite the rough surface, the text engraving turned out quite well. Then I tried engraving a brass coin. I didn't align it perfectly. You can see the logo is slightly shifted to the left. I couldn't find suggested parameters for brass, but based on my previous tests with 2 watts and 3 watts IR lasers, I slowed it down for the 1.3 watts module and used 300 millimeters per minute with 100% power. It engraved quite slowly, but since the coin is only 38 millimeters in diameter, the job took about 14 minutes to finish. The result is decent, though I might slow it further to 200 to 250 millimeters per minute to reduce the uneven marks. I didn't spend much time aligning it, which is why it ended up slightly shifted upward and to the left. Since the IR laser can also engrave on acrylic and leather, I used the same materials I tested with the diode laser and engraved them again using the IR laser. For acrylic, the IR module performed better. The logo is small, smaller than a quarter, and even though it's much smaller than the 87 by 87 millimeter version engraved by the diode laser, the lines are sharper and more defined. I also engraved some text on a camera light with an ABS enclosure using the suggested 4,000 millimeters per minute and 100% power. Engraving on ABS produces great results with the IR laser, even though it's only 1.3 watts. However, for leather, the result from the IR laser isn't as good as the diode laser. The IR is much slower at 1,000 millimeters per minute, while the diode can engrave at 20,000 millimeters per minute. It's not bad, but it's definitely not worth the extra time. The engraving done with the diode laser actually looks better. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. This machine comes fully assembled and is ready to use right out of the box. It's a small package but packed with features. The enclosure is compact with a small footprint, though the working area is smaller at 300 by 210 millimeters. It also includes tilt sensors, vibration sensors, multiple flame sensors, and a cover open sensor. All of these sensors can have their sensitivity adjusted or be disabled through the app. 2. Besides working with laser Gerbil and Lightburn, it also comes with its own app that supports Wi-Fi. Currently, the app can handle some simple engraving tasks. It's slightly better than average, but I still prefer using my PC with Lightburn when working with this machine. I'll talk more about this later. 3. There is a micro SD card slot at the back, allowing you to copy your frequently used files and start jobs directly from the touchscreen. This way, you don't need to connect a USB cable to your computer or move back and forth between the machine and your PC. 4. The IR laser module is backward compatible with older order machines since they use the same connector. This means you can upgrade your Laser Master 2 or 3 with the newer IR module. However, this may not be a good thing if you don't own any older order machines. I'll talk more about that later. 5. The base plate can be removed. If you need to work with taller materials, you can use blocks to raise the machine, effectively increasing the total working height without limitation. 6. It comes with a comprehensive material parameter table. The only material I couldn't find listed was the coated aluminum card and the brass coin. The parameters for most other materials are spot on, making it a helpful reference for beginners to have included with the machine. Now for the cons. 1. The air assist pump needs to be turned on and off manually. There is no switch on the pump itself, so you'll need to add a switch to the power cord of the pump or use a power strip with individual switches. It would be better if the pump's power were connected to the machine so that the G-code could control it automatically, turning it on for cutting and off for engraving. 2. I expected the laser modules to be connected to the X carriage plate using quick connectors, allowing you to swap tool heads easily, like on the Snapmaker or X-Tool S1. Unfortunately, it uses 2 different sets of connectors, so you have to disconnect the entire cable along with the tool head and then use zip ties to secure everything. This isn't a good idea if you need to switch between tool heads frequently. 3. Since this machine supports different laser modules, for example the 10 watt and 20 watt modules are different in size, you need to adjust the limit switch plate manually. However, if you don't leave a small gap and push it all the way to the end, the limit switch won't trigger properly, which can cause homing issues. 4. There is a phone app that's supposed to be better than average, as the manufacturer is trying to integrate the camera into the app and enable batch production. However, it's not as reliable as using your computer with a USB cable. For example, the camera doesn't always work with the app, but it works perfectly every time with Lightburn. The Wi-Fi connection also occasionally disconnects and requires restarting the machine. I noticed the app is updated frequently. The most recent update was about 3 days before I released this video. While the Wi-Fi connection has improved, the features are still very limited. I still can't find a way to draw basic shapes like circles or rectangles for cutting, let alone automatically add an offset contour to cut the job out. It can handle simple engraving tasks, but it still has a long way to go before it can fully replace computer software. In conclusion, this is a simple but functional machine. If you're familiar with the traditional workflow of Lightburn or laser Gerbil, it performs just as well as an open-frame laser engraver, but with the added benefit of an enclosure. I'm not a big fan of using limited feature mobile apps to control a laser engraver, so the app's limitations don't bother me much. I just mainly use it to enable or disable the sensors or adjust their sensitivity. To me, the main drawbacks are the process of changing laser modules and the need to manually operate the air assist pump. However, considering the price, $439 for a fully enclosed laser engraver, it's still worth checking out if you're in the market for one, especially if you're on a tight budget and want to start with the basic 10-watt diode laser module. You can always add a more powerful module or the IR module later. I included a link to their website in the description below. Don't forget to also check out AuroraTechChannel.com, where you can track prices for popular 3D printers, laser engravers, and CNC machines to find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.